It's a microcontroller starter kit coming with lots of components. It comes with a DVD tutorial. See link below video if you want to purchase the Elegoo L-Kit 003 Uno Project Super Starter Kit. In this first video I will demonstrate only some of the possibilities a treasure box like this one offers for projects using a microcontroller. Your imagination sets the limit. The core element is the microcontroller. The processor is an Elegoo 328P with 20 pins that can be switched into input or output mode through software. Six of those pins can be used as analog outputs by using pulse width modulation. While another 6 pins can be used as analog inputs. A clock speed of 16 MHz, 32 kilobytes of program memory and 2 kilobytes of internal RAM. Sound like this is a poor computing machine, however those specs are more than sufficient for many applications. The tiny computer receives software code through a serial interface internally joined with 2 of the GPIOs. An onboard USB interface can be used to connect the serial pins of the microcontroller to a host computer. The board is named Arduino and it can be programmed with the Arduino development environment. Electric power is either drawn from the USB interface or from an external DC voltage ranging from 7 to 12 volt. An adapter for a 9-volt battery is included in the kit. The microcontroller doesn't need a connection to a host computer to execute software code. A breadboard and jumper cables are part of the kit, and with that you can construct circuits quickly. The journey begins with the fascinating world of physical computing, starting with a blinking LED. Sounds simple, but there are many things that can go wrong, even with a circuit composed of no more than 2 devices. You must note the correct polarity of the LED, and you need to know the resistance value for a series resistor between LED and pin of the microcontroller. If you made one LED working on a microcontroller, you can simply scale up the circuit to multiple LEDs. Inside the box you can find 5 red, 5 yellow and 5 blue LEDs. Here I have used 12 LEDs in total. 6 of the GPIOs can be used as analog outputs by pulse width modulation so that you can dim the LEDs and create a tiny light show. With 3 LEDs in one case, having the colors red, green, and blue, you can mix nearly any color. Multiple LEDs in a matrix can be used as a screen. The version shown here has 8 by 8, thus 64 red pixels in total. If you learned how to switch LEDs, you can also switch a motor. Four output pins have to be connected to the control interface of the stepper motor shown here. Depending on the switching sequence, the motor turns clockwise or counterclockwise. The frequency of the pulse sequence governs the speed of the motor. Servos are compact geared motors that can be controlled through a single output pin. The control signal is pulse width modulated, having a frequency of 50 Hz and a duty cycle ranging from 5 to 10%. With that, the servo lever can be commanded to any position ranging from 0 to 180 degrees. Giving the microcontroller input from its environment makes computing even more interesting. The simplest input device is a push button. You can wire up a button as a switch, which is used when writing software code. If all is done correctly, you can trigger a software event by pushing the button. By pushing the button, the LED lights up. As soon as the push button is released, the light turns off. Well, that's not really exciting, since you don't need a microcontroller to turn an LED on and off. However, with software code you can trigger multiple events by simply pushing the button more than once. You can use a sensor instead of the push button. Here it is a light-sensitive device. Whenever light hits the sensor, the situation for the microcontroller is identical to pushing the button in the previous experiment. Because of the bright light in my photo studio, I am covering the sensor with a tiny paper cap. And after turning off the light, the experiment can start. Now, you can remote control the microcontroller with an electric torch. If you don't want to create a pulse train manually, you can use the remote control to make the auto pulse train using the microcontroller. 6 of the inputs can be used to convert an analog voltage into a digital number instead of detecting nothing but an on or off state. Here, a potentiometer operates as voltage divider and so creates a voltage ranging from 0 to 5 volts at the GPIOs of the microcontroller. With that, the angle of rotation can be detected. The potentiometer moves in unison with the lever. A simple push button triggers changes the software so that the servo starts rotating into the opposite direction of the potentiometer. A joystick is made of 2 potentiometers. This can control the servo through horizontal movement of the stick, and the stepper motor through vertical movement. This joystick has also a built-in push button, so that you can swap the direction of movement by software. Instead of the LED matrix of a previous experiment, you can also use the 2x16 character liquid crystal display that's in the box. With that you can display the readings on the analog inputs. Part of the kit is a water level sensor. This detects the height of the water in the glass. A temperature sensor is connected to a second analog input. The sensor readings are displayed as raw values ranging from 0 to 1023. Calibration of both sensors is needed to get the conversion factor to temperature and water level height. Numbers can be displayed with a 7-segment LED. Either using a single digit or using the module having 4 digits. It's all that's needed to create a simple voltmeter. The current a GPIOs can deliver is limited, thus you can't drive powerful peripherals directly. Here, a relay is used to boost current and voltage for a wiper motor. To prevent the motor from being actuated by unauthorized persons, access to the relay is not granted until the correct code is typed on a 4x4 push-button code pad. Unlocking the motor can also be done using a radio frequency identification keychain fob that is included in the kit. That chip sends the unlock code to the microcontroller as soon as it comes close to the scanner. A real-time clock module is also part of the starter kit. The microcontroller keeps timing even without power or a battery connected. With that, you can implement real-time functionality. A simple clock turns into an alarm clock by connecting the buzzer to the board, and with the sound level module you can turn off the alarm signal by voice. In this video I demonstrated no more than a couple of ideas that can be turned into working circuits with the starter kit. Thanks for watching.